All right. Okay, welcome everyone. So, our first lesson of exam revision, and today's the 4th of September, exactly 2 months until you'll be sitting down doing your exam. So sort of this time, this time in November, you'll have half an hour to go for your exam. All right, so I said I've got a very rigorous plan for the first few weeks the last few weeks of term here, and then we segue into a bit of self-directed revision. So if we just highlight what we're going to do through here today. So we're week 7, Wednesday. All right, that's where we are today. And I'm going to go through and give a very comprehensive description of what our plan is for the next 2 weeks. I'm going to point to where all of the resources are. I'm going to talk about sort of just general stuff for the exam. And then we're going to spend some time working through the 2018 exam. That's going to be sort of open book. The 2018 exam is my favourite exam. So just maybe we'll start with our summary, and then we'll talk about some stuff about the exam. So this Friday is a student-free day. We won't have a lesson on Friday. And then next week, we're basically dedicating a double lesson to reviewing each unit that we had a test for. So you'll notice on Tuesday next week, we'll go through chapter 2. That's going to be calculus revision. So that's chapter 2, just the rules of calculus. Then on Wednesday, we'll look at the applications of calculus. And on Friday, we'll look at specifically chapter 7, discrete random variables. Following that, we do integration together, both the rules and the apps of integration. They're both short. Continuous random variables is pretty fresh in our minds for Wednesday of week 9. Class party Friday of week 10. I've got a bit of a quiz that we go through. We've got lots of games we play. It's always lots of fun. Then the following week, week 10, that's going to be our first sort of official trial exam together. So we'll start at 12 o'clock and we'll sort of try go for, until the end of lunch. You don't have to stay here, but you're invited to facilitate that exam situation. And then Wednesday's lesson going through the exam, and we won't have a lesson Friday. There are 2 tutorials in the holidays. I've said yesterday we'll be going through an exam in its entirety. So make sure you register interest, both with myself and Mr. Virgo if you're attending. Then week 1, term 4, we're back here, just normal lessons, and that's going to be largely self-directed learning. Week 2, on Tuesday, you have your exam, trial exam. All right. Week 3 is optional tutorials that you're allowed to come in for, I recommend you do, where we can go through your trial exam and so forth. And then week 4 is when the exam occurs. Okay, so that's a summary of what our plan is. And this booklet has everything we're going to work through to recap all of the units. So you'll be bringing this along. Okay, so for the exam, it is a 2-hour and 10-minute exam. So this changed in 2020. They moved from a 3-hour exam to a 2-hour exam. However, none of the content changed. So the course began in 2017. So 2017, 18 and 19 were all 3-hour exams. All of the content is relevant, it's just the exams are longer. All right, so I still recommend those exams. They still have suitable questions and so forth. Now, for the exam, you get 2 double-sided handwritten sheets of notes. Okay, so 2 double-sided A4 handwritten sheets. Has to be handwritten. Now, we do, and we have historically provided you with card, like thick card rather than just paper with grid printed on it, so that you can, so that when you write on it, it's not popping up on the other side. So we'll provide that for you in coming weeks. You get a formula sheet provided for you by SACEboard. This is what it looks like. Okay, so that's everything that they will provide for you. You won't need to write that on your cheat sheet. So yeah, some confidence interval formula there, calculating standard deviation and so forth. Okay, as far as calculators go, you're allowed to take 1 graphics calculator and a scientific calculator if you want to. If you want to just perform quick operations on a scientific calculator, you're welcome to. As far as a unit circle goes, you're not provided one, obviously. So if you feel that it's something that you rely on when answering trick questions, it's up to you to draw it on there. However, there are strategies to, just solve those quickly in your head, or just draw one segment of it and so forth. I can go through that with you if that's what you have. Now remember, in an exam, okay, the goal, having marked exams, okay, so as a marker, my goal isn't to try and take marks off or try and see where you've lost marks. The marker's goal is to look for evidence to support the examiner, the person who's doing the exam's work, okay, so my goal is to find the marks. So that means your goal is to just get as many marks as you can, all right, that's your goal in the exam. And so we have lots of things. We have things like, when we're doing a test, we say stuff like 1 mark per minute, okay? So if something's worth 1 mark, you shouldn't be spending more than a minute on it. Those kind of things to keep in mind. Now my last dot point there says facilitating the exam scenario. So as we get through the summary and you're starting to perform practice exams, you really want to facilitate that exam situation. So that means you're sitting down for a block of 2 hours. You're not getting up and getting a snack. You're not scrolling through TikTok halfway through. You're not listening to music, okay? Those are things you won't be doing in the exam. And so you've got to familiarize yourself with that situation, all right? Make yourself comfortable, competent, because that's when you're really going to develop those sort of problem-solving skills, that wrestling with the questions that you encounter. Okay. Any questions about that or general exam questions about how long and how many marks and so forth? All right, very good. So let's flip the page, and what we'll take you through next is a summary of resources that we have here. So this is our OneDrive shared folder. We've all got access to this. We've been hitting it for the solutions and so forth. We're going to be hitting it heaps for the exam as well. Now what we have firstly is a list of all of the exams that have content that matches the course. Okay, so you'll notice we have SACE from 2023 through to the SACE sample of 2020. These are SACE made exams that are 2 hours long. Then we have the MASA ones, 24 through to 2020. Those are made by the Maths Association of South Australia. They're pretty good. They're 2 hour exams as well. They match the course. And then you have the SACE 19, 18, 17 exams, which are 3 hour exams, as well as some MASA and another assessment task designer, QATs. So they're all there. You can have a look at all of them. I think a suitable goal might be, if we're facilitating the exam situation and you've got here, 15, 20 exams, a suitable goal would be to get all of those done in the next 2 months. Okay, it might just be hitting one, 2 a week, just sitting down for 2 hours at a time, just doing as much as you can, and then focusing on what you need to improve from it. Now, I will print anything that you want printed. Okay, so you just need to ask me. So I'm in my methods shared folder. If we go into exam, all right, in the folder called exams. Okay, this is where all of the exams are. So you have all the MASA ones, you have all the SACE ones, and you have the QATS ones. We have old math studies exams as well, and we have worked solutions to those exams too. So there's lots of stuff in there. I'm very happy to print these booklets out for you if you would like them in booklets. And I'm very happy to, for you to work online or whatever you want printed, I'll print it for you. Okay, so there's lots of exams there to work from, so I'll just mention quickly, for your formal trial exam, which takes place in week 2 of term 4, we will do the 2023 exam. Okay, so that's the one that we're going to go over when you're up here under exam conditions in term 4 of week 2 of term 4. So, don't go and look at that one or find the answers for that. That's the one that we will do up here.
For our formal exam weeks, we have lessons.
No, because it's Monday. Yeah, so it might be you have tutorials with your other teachers, but our exam is Monday morning, 9 a.m. So, yeah, so week 3 we can have lessons, but week 4, that's it, Yeah, so you don't have any scheduled lessons, but you're allowed to come in at that time, to see teachers and so forth. Okay, so we've got the exam there. Maybe just one other thing I'll mention quickly about the exam. You'd notice if you've had a flick through of the 2018 exam, it will come in 2 booklets. So I've just combined this to one so you don't have lots of loose papers, but this will be one booklet, okay, up to there, and then this will be another booklet. So there'll be 2 separate booklets that you have, And the reason they do that is it divides up the marking. Okay, so you have one marker do booklet 1, another marker do booklet 2. All right, so then let's focus on the extra resources part, and I'll take you to where that is located. So it's not in the exam folder. I tidied this up at the start of this year, I'm pretty sure. It's in the miscellaneous extra resources. And in here is just so much stuff, okay? It's just, you just see it's just this big assortment of files. But I want to draw your attention to a few of these in particular, which are fairly comprehensive resources. So the first one is the conjecture booklet. You can expect a conjecture question. Okay, there will be a conjecture question. There's been a conjecture question for the past, N exams, so we have good evidence to suppose there'll be another one. All right, so conjecture question booklet. You've all got a copy of that, unless you've lost it. But anyway, we can find that. The graphing relationship booklet. Again, very common to conjecture questions. I'll draw them out more when we're doing applications of calculus revision, but they're very frequent exam questions. So look, here we've got graphing relationships. I've updated that in 2024. That's the booklet there. Conjecture questions, updated 2024. That's the booklet there. You've got solutions to it. Okay, solutions to each booklet. The next one says natural logarithms and exponentials booklet. Now, let me just talk about what this booklet is. So if I open it up and I'll show you. So this is a question obviously around natural logs and exponential questions. But where did I get these questions from? So if I just talk about time frame, I said the methods course started in 2017. Okay, and so we've had methods all the way up to 2024. So that's why we're sourcing those exams. Prior to that, the course was called Math Studies. All right, and this basically goes all the way back to 2002. And so these booklets, what I've done is I've gone through the Math Studies exam and I've pulled out the questions that are relevant for specific topics. So conjectures, for logarithms and exponentials, for trig functions and so forth. So that's where I've harvested those exams from. So you won't necessarily encounter those questions in these following exams. Okay. So there's natural logs. We've got questions specifically on statistics, questions specifically on trigonometry on the unit circle. A couple of other resources. We've got the Adelaide Tuition Centre resource. That's from a few years ago. So you always have a couple of students interested in going to the tutorials in Adelaide. So where's that one? I'll find that one. Tuition Centre resource. So I'll just show you what they sort of give you and what they go through. Why is my T not working? Tuition Centre resource. Alright, so have you guys heard about that? The tutorials in Adelaide over the school holidays, might be hear about them in coming weeks. Alright, so you can go to them if you want to. I've had students go in the past, they say, yeah, because they found it useful, they get given more resources. And what it is, it's sort of like days intensive where you're there with they tend to be professors or teachers from other schools, and they'll go through fairly intensively, like 3-hour sessions, lots of different strategies and questions. It does cost a bit of money. You can go to it if you want to. Taught you everything you need to know, so you won't learn anything new, but it's a good way to revise some strategies and so forth. And here's the resources that they do go through anyway. Okay, so that's the Adelaide Tuition Centre resource. What else do we have? We've got the Old Math Studies exam. And just one more resource I'll point out is the SACE sample questions, which is the Math Method sample set questions 1, 2 and 3. This was a resource released by SACE just with an assortment of exam style questions. Okay, so there's lots of stuff in there in that book, in that folder. Okay? So what our plan is, right, is we're going to be very precise about recapping each area, and then it's like, where are my gaps? Where do I need to focus my efforts? And so you can localize your attention to specific kinds of questions, and then you can start doing exams that throw them at you in all different, all combined together. And that tends to be the hardest thing about the exam, is that it's not just you're not just doing a question on calculus, you're doing a question on calculus that asks you an area under the curve, and all things are combined together. So that's what makes it tricky. As well as I've just provided a checkbox down there for our tests. Hopefully you've sort of done most of the tests in anticipation of the test you did this year, but they can be a thing to look back at and find questions where you might need prompts or you might need a little bit of help there. Okay, so are there any questions about resources? Are there any questions about the exam at this stage? Okay, so I don't want it to be overwhelming. Okay, it might look a bit overwhelming, but remember, we've got 2 months. We're just going to take it step by step by step. And so what I would like to do today, on our schedule I said we'd do it next week when we do calculus revision, but I think we'll just do the chapter 1 revision today. Okay, so that's on the page 3 of your booklet. We'll just go through these where we're summarising exponential functions, logarithmic functions, and trigonometric functions, those basic skills. We'll summarise those, and then we'll get you guys to crack on, have a look through the 2018 exam, do as much of it as you can. That sound all right? Excellent. Okay, so in chapter 1, chapter 1 is 1A, 1B, 1C, 1D. It's all background concepts. We start with exponential functions, and the only real takeaway that I want to emphasise there is e to the x, or even a to the x, will always be greater than 0. If you sketch the graph of an exponential function, it's always going to be asymptotic to the x-axis, unless we provide a vertical or horizontal translation. When it's reduced to this, it's always greater than 0, okay? All right, then we have some reflection on logarithms. Now, most of the logarithms that we deal with will be ln, but let's do a quick recap of these. So when we have log written by itself, if there's no base there, that means log in base 10. And so it means we need to express what's in brackets here as a single power of 10. So I'll really draw this out. This is 10 times 10 to the half. That's what's going on there. So we're going to use the index law where we add the powers together. Now 1 plus a half is 1 on 2, 1 and a half, 3 on 2. Now that we've expressed it as a single power of 10, it simplifies to 3 on 2. Alright, so that's A. For B, we have ln of 1 on e. So this is a logarithm in base e. We need to express what's in brackets as a single power of e. So we're going to take it to the top of the fraction and make the power negative. And ln e to the x simplifies to x, so ln e to the minus 1 simplifies to minus 1. Okay, we have 3 ln 2, take away ln 4. So for us to combine these logarithms, first we need to move this 3 to be the power there. So we're going to have 3 ln 2 to the power of 3. Now 2 to the power of 3 is 8. And then when we have log A take log B, we can write it as log of A on B. So it simplifies to ln 2. Maybe I'll just draw out another way that we can emphasize that, because log laws pop up, all right, in exam. When you can't crack a log question, it's got something to do with a power or combining logarithms and so forth. If we have 3 ln 2 take ln 4, let's think about this. ln 4, we could express that as ln 2 squared. Okay, I can now bring that 2 out the front. So I have 3 lots of ln 2 take 2 lots of ln 2. So if I have 3 lots of ln 2 and I take away 2 lots of it, I'm left with 1 lot of ln 2, right? ln 2, okay? So just drawing out the relationship between those operations of logarithmic laws. Okay, then we have, in D, we have an exponential equation. Exponential because we have, an exponent here, and it's an equation, it's equal to 9. Now there's 2 ways we can solve this. All right, we can solve it by equating the bases, or we can solve it by using logarithms. Let's do both. Okay, so if we're going to solve it by equating bases, what we want to do is make this have the same base as this. All right, well 9, that's the same as 3 squared. Now because the bases are equal, the powers have to be equal. Solve for x. Okay, if we're going to solve it using logarithms, what we're going to do is log both sides straight away. So that's the first strategy. Here's the second strategy. If we log both sides, we can move the x take 2 out the front, right? Divide both sides by ln 3. And then plus 2 to both sides. Now, if you evaluate that in your calculator, you will get 4. Even then, like, how does that simplify? ln of 9, think about that. ln of 9, that's ln of 3 squared. The 2 can come out the front. So then you have 2 ln 3 on ln 3, cancels, 2 plus 2, 4. Okay, so they're all connected. They're all drawing on the same process. Yeah, now I've performed the natural log. We can perform the log in base 10. It doesn't matter, you will generate the same answer. All right, very good. Then 1c, yeah.
Can you do the log in base 3?
Yeah, absolutely. Yep, log in base 3. Yep, because that will simplify to x take 2. That will simplify to 2. Very good. Yep, absolutely. Yep, all right, so from 1c, logarithmic functions. So we looked at log of x, the graph of log of x. We looked at the graph of, log in base 2 of x. We looked at the graph of ln of x. Now, one thing we just need to emphasize is that ln of x exists provided x is positive. So you can't have ln of a negative number. That's what pops up there. Just as the exponential is positive, okay, it exists above the y-axis. This function is positive, exists provided x is positive. So this function exists if y is positive, this function exists if x is positive. And they are the inverse of one another. Now what I mean by that is if you graph e to the x and you graph ln of x, this is what they look like. They're symmetrical about the line y equals x. Okay, let's solve these. 1D, trigonometric functions. So we've got sine of 2x equals half. Now we're going to find all solutions to this. We're going to find all solutions that make that true. So if we were just considering one revolution, we would have 0 to x to 2 pi. However, we're considering 2 revolutions, aren't we? So we need to double it. Now, when is sine positive half? So if we look at our unit circle, sine value is y, half is here, so it occurs here and here on the unit circle. So within one revolution, all right, what we would have is we would have 2x is equal to pi on 6 and 5 pi on 6. All right, so we're getting those angles from the unit circle. Now, however, because of this 2 in here, we've had to double the domain, so we're assessing when is it going past half again, and that's going to be at pi on 6 plus 2 pi and 5 pi on 6 plus 2 pi for that next revolution. Okay, so I'll simplify all of those. So that's going to be 13 pi on 6, and this one's going to be 17 pi on 6. And this is what 2x equals. So in order to solve for x, we have to divide it by 2. So we get pi on 12, 5 pi on 12, 13 pi on 12, and 17 pi on 12. Now, that's within the first cycle. That's within 0 to 2 pi. However, if we want to allow for every solution, we're going to put plus k2 pi, where k is an integer. Okay, so these are specific solutions. This allows for every solution. Now this is one way of describing it. There is an alternative way. You don't have to include those answers. You can just go plus k pi. But this is a perfectly suitable way of describing it. So what do we do there? We're solving when does sine of 2x equal half. We're looking at the unit circle and we go, yep, it's half there and there. We find those angles. Okay, pi and 6, 5, pi and 6. But then because of the 2, we have to consider 2 revolutions, right? So we go past it and past it, simplify those answers, divide by 2. Very good. All right, theta is 5 pi on 6. Find tan of 5 pi on 6. So if theta is 5 pi on 6, we want to evaluate tan of 5 pi on 6. Now you could just do this on your calculator, but let's reflect on how we would use the unit circle to do it. 5 pi on 6 is here. Now tan is sine divided by cos. So here we want the x value and the y value. So I told you just before that y value is half. That's the sine value at 5 pi on 6. And the x value is minus root 3 on 2. So what we have going on here then is we have the y value divided by the x value, right? Sine divided by cos. So we have half on top of minus root 3 on 2. And it's just a matter of doing AD on BC. Now when people are confronted with this, they're often like, where does the negative go? Does it go to both of them? No, okay? If you want to process it, it only needs to go to one of them, all right? But even then, I would just think you've got a positive number divided by a negative number. The result is going to be negative, okay? So just pull that negative out the front straight away. And then you've got your AD on BC, and we'll simplify to 1 on root 3. Okay, so that's B, and then for the last one, just before recess, we've got a graph here. We need to find its equation. It's a sine equation. Okay, now what we have is we have 2 wavelengths in 2 pi. Okay, so here's one wavelength in pi, and then we have 2 wavelengths in 2 pi. We have a principal axis of 1. Okay, that's the line y equals 1. And the highest it goes from 1 to 4, and the lowest it goes is to minus 2. Alright, so a basic trig function is like this, a sine bx plus d. Alright, we don't consider horizontal translations. Now, a is the amplitude. Alright, so the amplitude is the distance from the principal axis to a peak, or the principal axis to a trough. So the distance there is 3, the distance here is 3, our amplitude is 3. B is related to the period. The value of B is how many wavelengths are there in 2 pi. So we have 1 wavelength in pi, we have 2 wavelengths in 2 pi. So B is 2, and then D is just what's the vertical translation, or what's the equation of the principal axis? Positive 1. Alright, so we're sort of all remembering those skills. Yep, a lot of them we haven't touched on for a long time, especially this kind of stuff, some of the trig stuff. But particularly solving trig equations does pop up occasionally. So it's something we do need to touch on. Very good, I'm going to stop there and probably stop there for recess. So our plan for the rest of today's lesson then